All right, good evening and welcome to today's class. I trust you had a good day today. Let's quickly attend to this particular question. Just a simple one at that. A simple question. Let's attend to it. Now, from this diagram, you can see we have three triangles in one. All right, one is A, B, C. All right. Now, this line here is a line. We have only A as one end of that line. Let's actually use D as another end of that line. Okay, so we have triangle ABC, another one ABD, another one ADC. All right, so I have to find the value of angle alpha and angle beta and angle alpha. Now, the point is this: though we have three triangles, but we have two right angled triangles here. This is one, there's another one here. Is that okay? All right. Now let's go on. Now our aim is to find the value of alpha and beta. Now from the triangle ABD, we have two sides here given. And that's those two sides, in that triangle where two sides are given, that's where alpha lies. All right. Now remember our simple terms, SOHCAHTOA, simple acronym that we use to solve trigonometric ratio. Let me break it this way. Now, sine says opposite over hypotenuse. Now, alpha is a reference angle here. Here becomes opposite, here is hypotenuse. That means sine is going to work on this triangle ABD. All right. Now, by bringing sine here, we want to find the value of this line AD. Is that okay? So let's solve. Sine beta is equal to opposite over hypotenuse. This implies that sine beta is equal to, opposite here is 5. Hypotenuse here is what's it called? 11. Is that okay? Now let's actually go. Now in this place, we're going to have that sine beta is equal to 5. 5 divided by 11 is going to give us 0.4545. Now to have my beta now, I'll take sine inverse of this, which is sine inverse of 0.4545. All right, therefore beta is equal to, if I take sine inverse of 0.4545, beta is going to give me approximately 27 degrees. Now, to press this in calculator, simply press second function or shift, then press sine, put this number. I repeat, to press sine inverse in your calculator, press where they wrote shift or second function, then press sine, then put this number. You're going to have this. Beta is approximately 27 degrees. This is gotten. Now, to get this side line AB, we are going to employ Pythagoras theorem. All right. Now, to get line AD, which is written this way, we employ Pythagoras theorem. His theorem says, okay, let me use here. hypotenuse squared is equal to opposite squared, then plus adjacent squared. Okay, now let's go. Hypotenuse, opposite, adjacent. So I'm going to have 11 squared is equal to 5 squared. Let's use x for adjacent, which is unknown. S squared. So 11 squared is 121. 5 squared is 25 plus s squared. If I collect items, I'm going to have that s squared is equal to 121 minus 25. Alright? So what value does it give me? This will give me 96. So to get my s, I will take square root of 96. Therefore, x is approximately 9.8. That means this line here, line AD, will give us approximately 9.8. You can see use 10 anyways. Now, let's go. Having known this line and this line, you can get the value of alpha. Now, this value, 9.8 and 20, alright, are within the triangle ADC, where alpha is also found. So from there, you can get the value of alpha. Now, here becomes the opposite because alpha is reference angle. This side is facing the angle, alright? So here becomes my opposite, then adjacent. Now, the trig ratio that gave that is tan theta. So that means since we have alpha here, we're dealing with tan alpha. Is that okay? So tan alpha is equal to opposite over adjacent. Therefore, this implies that tan alpha is equal to 20 being opposite, adjacent, which is 9.8. Is that okay? So this will give me, carefully press the calculator, we are going to have 2.0408. Okay, that means tan alpha is equal to 2.0408. So alpha is going to be tan inverse of 2.0408. Tan inverse is when you press shift or second function, then press tan. Alright, put this value. I'm going to get the value of this alpha. So when I find the tan inverse of 2.0408, I'm going to have approximately 64 degrees. Alright, at this point, I've gotten my alpha to be equal to 64 degrees and my beta to be equal to 27 degrees as earlier solved. Okay, it's just a simple question, but at least to let you make use of those trig ratios that we must have learned in the past. Alright, kindly watch through and see you in the next class. Bye for now.